Developing a Sampling Plan for Quantitative Research Guide for Health Researcher. So for this topic, we are going to discuss the following objectives. First is we are going to define basic quantitative research sampling concepts, differentiate the two quantitative research sampling designs, apply the knowledge gained on planning sample size in quantitative research, and calculate a sample size using Yamin formula. So before we are going to discuss the basic sampling concepts, let's differentiate first quantitative research from qualitative research. In quantitative research, here, the researcher seeks to select samples that will allow to achieve statistical conclusion, validity, and to generalize the results. Whereas in qualitative research, the researcher here is more interested in ensuring to develop a rich, holistic understanding of the phenomenon of interest. So in quantitative research, the researcher or health researcher needs to develop a sampling plan that specifies how the study participants are to be selected and how many to be included. While in qualitative research, the sampling decision is made during data collection based on informational and theoretical needs. For the first concept and basic sampling, we are going to define what is population. So this refers to the entire aggregation of cases in which a researcher is interested and is represented by a simple capital N. An example here is that if a nurse researcher were studying Filipino nurses with doctoral degrees, so the population could be defined as all Filipino citizens who are registered nurses and who have acquired a doctoral level degree. In relation to the concept population are the following concepts: accessible or source population and target population. When we talk of accessible or source population, this refers to the aggregate of cases that conform to designated criteria or attributes or characteristics that are accessible as subjects to the researcher or health researcher. Whereas target population refers to the aggregate of cases about which the researcher would like to generalize. It means not all target population is accessible or source population. So another concept in basic sampling in quantitative research is eligibility criteria. So this refers to criteria that specify the characteristics of the population or the attributes of the population. These criteria are theory-driven or study-based, so they also have implications for both the interpretation of the results and the external validity of the findings. Planning the eligibility criteria, the researcher or health researcher must consider the following. So the costs, the practical constraints or limitations, and then the people's ability to participate and design consideration. The inclusion criteria refers to a population defined in terms of characteristics that the people must possess or have, while exclusion criteria refers to a population defined in terms of characteristics that the people must not possess. Example here, a population defined to exclude people who cannot speak English. Furthermore, we need to define also samples and sampling. When we talk of sample, this refers to a subset or group or subset of population element or a group of element taken from the population. Whereas sampling is the process of selecting a portion of the population to represent the entire population and to make inferences of the entire population of interest. Element refers to basic unit about which information is collected. So in nursing, the most common element is human. So sampling frame refers to technical name for the list of elements from which the sample will be chosen. This list here could be either created externally or created by the researcher. Representative sample refers to one whose characteristics or attributes closely approximate those of the population. So this also refers to the sample as a whole, which represents the entire population. Sampling bias. This concept refers to the systematic overrepresentation or underrepresentation of some segment of the population in terms of a characteristic relevant to the research question or objective. And this usually happens when a researcher is not taking a systematic process of conducting a research or a study. So to simplify all those concepts, here's a photo representation. First, the researcher has to select a target population. So the example mentioned earlier was a researcher or nurse researcher conducting a research on registered nurses in the Philippines with the following attributes as to studying doctorate degree relevant or related to the nursing profession. So once the researcher has selected already the target population, the researcher has to ask himself or herself if this target population in terms to the characteristics or attributes are or is accessible to the researcher in terms to the collection of data or information. And this becomes the accessible population. The researcher now would ask if there is available list of the entire population that would serve as the basis on how to select a certain element or group of elements to become the sample of the study. So another photo representation here is the bowl of soup. If you're fond of cooking, particularly the bowl of soup, so one way to know that the taste of the bowl of soup is already good is that we are going to use a spoon or teaspoon, and then we are going to take a teaspoonful or a spoonful of soup from the bowl of soup and then taste it, and then we can now make an inference or generalize the whole bowl of soup if it's good for us or if the taste is already good for us. That's what we call sampling or taking a sample from the entire population. So let's proceed now to sampling designs. There are actually two general types of sampling designs. The first one is non-probability sampling, and this is also used in qualitative research, which involves non-random selection of elements, meaning to say, this type of design gives us a non-equal chance of selecting a sample from the entire population. And non-probability sampling has also various types. First is we have convenience, and then purposive, quota, and snowball. But it doesn't mean that non-probability sampling is no longer significant in conducting health research. It's probability sampling. Here, it involves now a random selection of elements, meaning each of the elements in the selected population has an equal chance to be selected as sample of the study that the researcher wanted to conduct. These are the following various the categories of probability sampling. We have simple random, systematic, stratified, cluster, and multi-stage. For sampling size, we need to include also the size of our samples. And according to Israel, we need to consider the following. So level of precision or the sampling error in health research, we usually set it to 5%. So if we are going to set our level of precision in 5%, automatically, so confidence or risk level now would be 95%, which means that 95 out of 100 samples will have the true population value within the range of precision. We need to consider also the degree of variability refers to the distribution of the attributes or characteristics in the population. The catch here is that the more heterogeneous a population, the larger the sample size required to obtain a given level of precision. Let's say if we are going to study the registered nurses all over the Philippines, we could say that these registered nurses might have, or by fact, have varied characteristics or attributes. The other catch here is that the less variable, the more homogeneous a population, and then the smaller sample size that will be needed in the study. So here also in our sampling plan for quantitative research, we need to include also the formulas to be used to calculate the sample size of the study. So I'm going to present Cochrane here, and the other one is Yamane, but we'll focus on Yamane. It provides a simplified formula to calculate sizes, and we're using a 95% confidence level and 5% level of precision. Let's discuss further why we are using Yamane. So based on the following articles or journals. This journal here talks of using Yamane as the formula for selecting the sample or the sample size. You'll notice the number 8 here. If we are going to refer this one to the references, this refers to the formula of Yamane Taro, another journal here. This is a probability sampling, a guideline for quantitative health research or healthcare research. So here, the general guideline for selecting a sample size, the following guidelines may be used for selecting a sample size. First is that sample the entire population when number is less than 100. So this could become our basis that if our population now has a size of 100, then we can use the formula Yamane. And then if 50% should be used for a population of around 500 and 20% for a population size of 1,500, and for 5,000 or more, the population size becomes almost irrelevant, and the sample size of 400 is considered adequate. Another support to this is this one. Here, this journal or article talks of 100 as the minimum size of your population in order for us to use the formula. So why do we use Yamane then as a formula instead of the popular Slovene? So here, in the article on the misuse of Slovene's formula, the author here made the following statement. As a last note from the author, from the literature reviewed by the author, there does not seem to be a person named Slovene who put forward the formula, so it seems that Yamane is the oldest reference in which the formula can be found. Other support to this from this article on sample size estimation using Yamane and Cochrane and Craig C. and Morgan. So they have been using Taro Yamane also as a formula. And we also have from sample size determination in survey research. Going back to our presentation, so that resolves. So here's the formula now of Yamane or Taro Yamane. So here, N here, or small letter n, is the sample size, and capital letter N is the population, and E is the level of precision in which we set it into 5%, or in decimal, that becomes 0.05. So let's use the formula then. So if we have a population of 386, for example, as your entire population, then we'll have to plot all those values, including the denominator, times the level of precision squared, that becomes 386 divided by 1 plus 386, then times 0.0025, and the answer you could decide then, so if there's a decimal point, so you could decide then if you're going to retain on 196, but here I decided on rounding it off even if the following number is less than 5. I think that would be the last slide of my topic on developing a sampling plan in quantitative research. Thank you so much. These are my references.